This is going to be the first in a two-part video in which I'm working with a frequency distribution. And what I want to do with this frequency distribution, which you see here in blue in the top left-hand side of this spreadsheet, is first calculate the mean, which is what I'm going to do in this video. And then where this video stops, the next one will pick up, and in that one I will calculate the standard deviation of the frequency distribution. Now, I just want to start off by saying these are estimates. First we're going to estimate the mean based on the frequency distribution. So I'm going to eventually put that answer right here. For estimated mean, that's coming from the frequency distribution, and then later the estimated standard deviation. So these are if we just connect these arrows, these are the two goals I have in this video, or these two videos. And we could compare those. Once we get those answers, we could compare those with the original, with the mean and the standard deviation, the exact values from the original data. And the original data is right over here. But we're going to start off by just assuming we don't have this. So we'll come back to this data later. But for now, let's just say we don't have any of the original data, and we just have the frequency distribution. So again, up here in blue, this is what we're starting with. So, like I said, we have none of the original data values, but we know that there are 18 numbers in our set, and those 18 numbers are somewhere between 2.4 and 2.49. We don't know what they are. And then the next 19 numbers in the second class, again, those are all somewhere between 2.5 and 2.59, but we're not sure exactly what those numbers are. Now, if you think about how to calculate the mean, which is the average, you add up all the numbers and divide by however many numbers you have. Okay, so a couple of problems. One, we don't have any numbers to add up. We just know there are 18 numbers somewhere in that first class and 19 numbers in the second class and so on. So the first thing we need is some numbers. All right, we need some x values. And for that, we're going to estimate them. So what I just highlighted right there, we're going to let x equal the midpoint of each class, or the halfway point between the lower and upper bounds. So in column D, let's insert some x values. And since the x value is going to be the midpoint of the lower and upper limits, I could find the average of those two numbers. And so that's what I'm going to do first. So we'll use the average function on Excel, equal average of location A3 and B3. So that should give us the halfway point, and that's 2.445, halfway between 2.4 and 2.49. So what that is saying is we're going to estimate that there are 18 numbers that are all equal to this, or 18 copies of the same number. And then we'll let Excel find the average of the next 5 pairs. Okay, so what I have here are the midpoints of each class. So those are going to be our estimated x values. Now, how many numbers do we have? Well, we're going to add up the frequencies. So we use the sum function for that, equal SUM, and then I'll select the data, or the values that I want to add up. So that's C3 through C8. Okay, so we have 70 numbers, 70 values in our set. And those 70 numbers consist of 18 copies of 2.445, 19 copies of 2.545, 2 copies of 2.745, and so on. Okay, so now we have numbers that we can add up and find the average of. So if you look over here on the right, I have the formula for the mean of a frequency distribution. And you see two different formulas, but it's actually the same formula because this n on the bottom is the same as the sum of the frequencies. That's what n is. All right, so I'm just going to focus on the one on the left, but it doesn't really make any difference because they're the same formula. So what that formula is telling us we have to do is 1, multiply each x by its corresponding frequency, by its corresponding f. Okay, so that's column C is the frequency and column D is the x value. All right, so that's what we'll put that in column E. So let's make this f times x. And then we're going to have to add them up. That's this Greek letter sigma, the one that looks sort of like an E. It's saying find each f times x, and there's going to be 6 of them, and then add those up, and then finally divide by n. Okay, so that's what this formula is telling us to do. Multiply first, and then add, and then finally divide by n. All right, so let's do that in Excel. Okay, let's get rid of this, free up a little bit of space. All right, so in column E, what I want to do is multiply, so equal the frequency times the x value. Because we have 18 copies of that first x value, that's why we're multiplying by the frequency. Okay, so we have a total of those 18 numbers, add up to 44.01, and then we could copy that calculation down and let Excel do it 5 more times. Okay, so step 1, multiply f times x, then add them up. So I'll put that down here in this cell, and we could make this cell a different color. Let's use yellow down here. So we're going to add them all up. So in this cell, we want the sum of f times x. So I'll use the sum function, sum, parentheses, select the data. So we're taking E3 up through E8 and adding them up. So that 186.95 is the numerator of this fraction. That's the sum of f times x. And now for the final answer over here in estimated mean, I'm just going to take that number and divide it by n. Okay, so equal the sum of f times x divided by n, which is the 70. And there's our estimated mean. So now, since we actually have the original data, so this blue frequency distribution is a distribution of this data on the bottom right-hand side. So now let's get rid of that x, and let's find the exact value of the mean, and that's coming from the data. It's much easier on Excel to calculate exact values. Excel doesn't work very fluidly with estimations. So that's why with the mean or the standard deviation of this frequency distribution, we're going to have to do it in steps because it is an estimation. But if we want the exact value of the mean coming from the data, well, we could simply say equal average, parentheses, and then select the data that you want to find the average of. And something very interesting happens. We get almost the same number. So we're only off by looks like 1/1000th of a gram. Remember, these are the weights of 70 pennies. So this is the same example I'm using from a previous video. So these, it doesn't say it here, but these 70 numbers on the bottom right are the weights in grams of 70 pennies. Okay, so just think about what just happened. We started with no original data. We estimated everything. That was column D, those estimated x values using the midpoint of each class. So none of those are actual data values. And when we calculate the mean based on our estimation, we get something extremely close to the exact value of the mean. And that's one of the benefits of using a frequency distribution. It's much more compact. You're not working with a huge list of raw data values, but you're giving up a little bit of specificity, a little bit of detail, but not that much, because when you look at these two numbers, very, very close to each other. All right, so that does it for this portion of the video. I'm going to stop it here, and the next video will pick up exactly where this one left off. The screen is going to look just like it does right now, and we're going to calculate the standard deviation of the frequency distribution. And notice, in the formula, there's an X bar. So we had to do the mean first, because this mean of the frequency distribution is now part of the calculation for the standard deviation. So we had to do the mean first, and now we'll use this result to calculate the standard deviation, and that's going to be the next video. All right, so that's it for now.